here we can see we have a single Portworx cluster running. This will back our Kubeflow deployment. It has 1.1 terabytes available to it, and it is running on our Kubernetes cluster where Kubeflow will also run. Now, if we take a look here, we can see that Portworx has 3 pods running in the daemon set. Each of them is part of the cluster. So we have a 3-node Portworx cluster. We've also made the default storage class so that dynamic provisioning needed by Portworx will work as it needs some place to put data for MySQL and things like that. So here's our Kubeflow deployment. We can create a demo profile or namespace. And here we have the dashboard for our pipelines and notebook servers and artifacts and things like that. There's a lot we can do here, but we're going to create a notebook server, which is run by Jupyter. We'll call it demo notebook. We'll create a custom image. We'll use a custom image that I know works with this training material, and create a new workspace and a new data volume. Now, both of these will be supported by Portworx, and we'll see in a minute. So if we click create on this, we can go back to our cluster and take a look at the PVCs available in the demo namespace. Here we can see that the notebook volume and the workspace volume. So the first one is for data sets and things like that. The workspace is kind of the home directory within the Jupyter notebook. Now, if we go back here, we can connect to our notebook, see that we have a data volume, but there's nothing in it yet. So let's open a terminal and we'll download some examples from Kubeflow. Then we can go back to our examples and go into the GitHub summarization training notebook, open that up, and here you can see a complete workflow for training and learning of a pipeline. Here we're going to go ahead and set this data directory to the one we created in Portworx, data vol 1. And here we can just see that it'll download the data, process it, define the model, train the model, and then we can shoot out some examples of predictions. So if you go ahead and run this all, I won't show this all in this demo, but the whole thing will run and produce the model, and then you have to create a image based off of this trained model, and then you can run this image in a Selden deployment to use the workflow and do predictions. This in the background will use things like TensorFlow as well as Python SDKs. Now you can see we have the GitHub issues data now within our Portworx volume, so we know that we can keep this around in case the notebook crashes and things like that. Here is the finished model I was talking about. It's already put into a image here, so we can run this as a Selden deployment. And this will deploy the classifier and make the prediction API available to REST-based calls. So once you deploy this, you will get another deployment inside of your demo namespace, as well as a service. And this service here is Selden and then a UUID running at port 9000. Now, if we go back into our notebook and go back into the terminal, let's go back to a new terminal. And this is also running on the same Kubernetes cluster, so we can hit that endpoint. So if we curl some test data to the /predict API, this will essentially use the model to summarize a GitHub issue. So we can do a couple examples here. The second one shows that it summarizes more because there's a lot more text in the second example. So here is kind of a full end-to-end workflow with Portworx backing the notebook itself, the data volume, as well as Kubeflow as a whole. So now one thing we want to think about is, what if Kubeflow crashes? What if our notebook crashes because we're running some training that uses up too much CPU and things like that? Portworx, I mentioned, was the default storage class here, and if you look in here, you can see the schedule policy names associated with this storage class. What this does is associate a snapshot schedule for every volume created with this default storage class. And here you can see the actual schedule. It will take a snapshot every minute and then every day at Thursday at 10:13 p.m. And it will retain two. So if we go into our Kubernetes cluster and take a look at the volume snapshots in the demo namespace, you can see our notebook volume as well as our workspace volume has already been getting snapshotted on the schedule. We can also go to the Kubeflow, and this is the services that back Kubeflow themselves, things like MySQL and MinIO. That is Portworx in supporting Kubeflow for your machine learning workflows with Jupyter and TensorFlow. Thanks for watching. Until next time.